All right. Okay, so number 44, first of all, it kind of gives you a little hint and it says factor. So that means that that one is definitely factorable. X to the third minus 64. So I do want to say, this is not a difference of squares because it's an x to the third. It's not an x squared. And then also, we can't do x box with this because it's not a trinomial. So because it has an x to the third, we're actually going to sing the song. So we take the cube root of the first and the cube root of the last and the sign from the middle. Then square the first, change the sign, multiply together, and square the last. And so this is what we get when we factor it. So again, I cube rooted the x to the third and the 64. So 4 to the third power is 64, so that's why that's a 4 there, not an 8. And we kept that middle sign. So it was subtracting, I kept it subtracting. Then I took the x and I squared it. I changed it from a minus sign to a plus sign. I multiplied the x and the 4 together, ignoring the symbol. Just x times 4 is 4x. And then I did 4 squared and got 16. And from here, unfortunately, you can't factor it anymore. And so we're ready to start writing answers. From our first parentheses, it's very simple answer. You set it equal to 0 and you add the 4. And our first answer is x equals 4. Now this problem has 3 answers because it has an exponent of 3, so we do need 2 more answers. Now unfortunately on these cube problems, the second parentheses can never be factored, and so you have to do quadratic formula for that one. We will expect you to have the quadratic formula memorized, right? So it's negative b plus or minus the square root of b squared minus 4ac, and then it's all being divided by 2a. And then the a would be 1, and the b would be 4, and the c would be 16. So that is negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 16 all over 2 times a. Hey, Sean, I'm running class right now, just FYI. Okay, so negative 4 plus or minus, and then 4 squared is 16, and 4 times 16 is 64, all over 2. 16 minus 64 is negative 48. And then we're going to factor tree the 48. Actually, we don't even need the negative signal. So 48 is 2 times 24, 2 times 12, 2 times 6, and 2 times 3. We're looking for pairs of numbers. So I have a pair of 2 here, and I have a pair of 2 here. So this turns into negative 4 plus or minus, and I've got 2 2's that escaped, so that's a 4 now. The negative sign can come out and become I for imaginary. And then we do still have this 3 on the inside. And then finally, our last step, all of my outside numbers, there are 3 of them. All of these can be divided by 2. And so my final answer, I'll write it over here next to the other one, is negative 2 plus or minus 2i rad 3. And this counts as 2 separate answers because of the plus or minus sign, right? So one of the answers would be negative 2 plus 2i rad 3, and then the other one would be negative 2 minus 2i rad 3. Now on the final, we'll probably give you the option of the plus or minus sign. We won't separate them out. It just takes less space to have the plus or minus sign. And that's number 44. So again, I brought home the 50 question packet that we can go through. So just let me know which numbers from that packet you'd like to see done. And I also brought home the 78 question packet. So if you need to see any problems from that one as well, just let me know which ones you need to see. Or what type of problem. If there's a type of problem, I can always just look in here and find one like that. Sure. So number 2 wants to know what type of number is 0.021553 dot 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 dot. And those dots are pretty important. And so here's how the number system works. So we have the smallest set of numbers, which are called the natural numbers, or also known as the counting numbers. And that's just numbers starting with 1. So 1, 2, 3, 4, and so on. So these are the natural numbers. And then, hey, put chapstick on, please, and lotion your hand. All right. After natural numbers, we have whole numbers. And whole numbers are just like all the natural numbers plus the number 0. So if we started counting at the number 0 instead of counting at the number 1, now we're talking about whole numbers. The next set after that is integers, and integers adds in negative numbers. So -4, -3, negative, like all the negative numbers. So if we also start including negative numbers, now we have integers. And then finally, the biggest circle is rational numbers. And rational numbers are anything that can be written as a fraction. So that includes fractions, obviously. And then, but it also includes, what is it called? Terminating decimals, decimals that have like a stopping point, like 0.5, where you're like, okay, that's the whole decimal. And repeating decimals, so decimals that have a pattern, so like 0.3 repeating, or even things like 0.212121, and that repeats. So those are all called rational numbers. So fractions, decimals that have a stopping point, and decimals that are repeating, a repeating pattern. And then we have this random circle over here. And these are not included in any of these other ones. And these are irrational numbers. And irrational numbers are never ending, never repeating decimals. Usually it's like pi or a square root of a number that we don't know the square root of. But in this scenario, it's actually this decimal. This decimal does not end, and we know that because of this dot dot dot. That means it keeps going. And there's not a discernible pattern. Like there's 2 5s, yes, but it's not like 0215553, 0215553, 0, and it keeps going like that forever. And so because this is never ending and there's no pattern, we call this irrational. And then all of the numbers that we had learned at this point in time were also real. So if I had to choose, I would say this was irrational and also real. So you're basically just trying to figure out like what's the first circle that this number can fit into, and then you kind of work your way out. So for instance, if I asked you to classify the number 0, you would say it's whole and also an integer and also rational and also real. Right? All negative whole numbers are integers, rational, and real. If I have a fraction, it's rational and real. If I have a number like 5, then we start in the very center. Natural, whole, integer, rational, and real. So you just like figure out where to start and then work your way out from there. Awesome. Okay. Yeah, so 5 through 7. So first of all, those would be graphed on a number line and not on a coordinate plane. So I know that we've been doing, since then, we've started doing like coordinate planes and things like that, but these would just be on a regular number line. So you can start with like number 5. So number 5 is just a regular inequality. It's just a single inequality, so kind of the same as like just solving an equal sign, like number 3. And so we just do, you know, the basics of what we need to do. And then we're going to divide by -3. Now the thing that's a little bit different about inequalities is when you multiply or divide by a negative, you do need to flip the direction that the inequality is pointing. So I'm going to make that a greater than instead of a less than. And then we are going to graph these on a number line. So I'd go to the 5. The or equal to means I need a colored in circle. And then you just look at which way the inequality is pointing. This one is pointing to the right, and so I'm going to shade all the way to the right. That was number 5. Number 6 is a little bit different because number 6 has 2 inequalities. This is called a compound inequality. And specifically, this one is an OR problem because it literally says the word OR in it. Nope, that's not the right number. It's a 1. Okay, so we're going to solve these each separately, just doing whatever we need to do to solve them. On this one, we're also dividing by that negative, so we are going to flip this around and make it go the other way. And so right now, it would appear that the answer is x is less than or equal to 12, or x is greater than 7. And we might just put a box around that and say, yeah, okay, that's the answer. But on these compound problems, especially, maybe not on number 5, but on a problem like number 6 or 7, the compound problems, you definitely want to graph it and kind of see what happens. So here's 7 and 12. What normally happens on an OR problem, what you want to happen, is you're going to get 2 circles, and the shading is going to go away from each other. So you've got your 2 circles, you've got a nice big gap in the middle where there's no shading, and the shading goes away. That's what normally happens on an OR problem. On this problem, though, when I go to graph it, I'm going to go to the 12, and I'm going to put a closed circle. And the inequality for the 12 is pointing to the left. So I'm going to go from the 12 and I'm going to go all the way down to the left. And then for the 7, I'm going to put an open circle. And the 7 inequality is pointing to the right. So I start at the 7 and I go all the way to the right. And it didn't happen what we thought was going to happen. The complete opposite happened. They did not go away from each other. They went towards each other. And on an OR problem, when they go towards each other, it's a special case, and we do not write this as the answer. And instead, you write all real numbers because we ended up shading the whole number line. Everything got colored in. All right, and then number 7 is another compound inequality, and I know it's compound because there are 2 inequalities in the problem. Now, it doesn't say a word, but the word for this problem would be the word and. So if it doesn't say a word and it has multiple inequalities, then that means it's an and problem. And on this problem, our goal is to get everything out of the middle of the problem. And because of the 2 inequalities, we actually have almost like 3 sections. And so we're going to move stuff out of the middle. And whatever we do to move something out of the middle, we have to do it in all 3 parts, the left side, the right side, and the middle. So like I'm going to start by moving the 13 by subtracting it, and I do it in the middle. I'm going to do it on the left, and I'm going to do it on the right. And then the next thing I'm going to do, I'm going to divide by the 2, but I have to do it in the middle and on the left and on the right. And so just make sure that everything you do in all the places. And so right now, this is what we think the answer is. But again, we should graph it and just make sure that it's a normal and problem. A normal and problem will have 2 circles with shading connecting them together. So what happens is you start at one circle and you go towards the other one, and then you start at the other circle and you go towards the other one, and then you just shade together. So that's what we're hoping is going to happen. All right, so here I have -9 is less than y, but we don't want to graph it that way. We do want to flip it around, so we're going to do y is greater than -9. And so if I start on the -9 and now my inequality is pointing to the right, then that would shade this way. And then on this side, y is less than 1/2. So if I start on the 1/2 and then it's shading to the left, and in this problem, what happened was exactly what I wanted to happen. I have my 2 circles and my shadings are going towards each other. So that's perfect. So this is a normal and problem. So we can just shade it like normal. And we could say that this thing up here that we wrote originally is our final answer. If that hadn't have happened, if you went to shade and they went in opposite directions like this and they did not connect together and it was an and problem, then you would say that there was no solution. So a special case for an and problem is no solution. All right, 36 we can do next. I'm going to show you 36 in two different ways because we can do it two different ways. And, you know, on your final, it's multiple choice. You're just going to choose the right answer. We'll have no idea how you got your answer, and we really don't, you know, we don't care what method you use. And so whichever one makes the most sense. So I'm going to show it to you the way that I taught it in class, and then I'm going to show you a different way, and then you guys just pick which way you like better. Because again, we're not grading your work tomorrow. We're just, we're not going to look at like, how did you get your answer? We're just going to, you know, hope that you got the right answer. So the way that this was taught in class was completing the square. And so to complete the square, we're going to add the 5 to the other side. And we'll put in some blank spaces here. And then on completing the square, we kind of jump around a little bit. So we're going to take the middle term, the positive 8, we're going to divide it by 2. And that's going to give me a 4. And then we're going to take the 4 and we're going to square it. And that gives me a 16. So I added 16 on both sides. On the left-hand side, 5 plus 16 is 21. And then to finish up the problem, we're going to subtract 21. And the final answer is y equals x plus 4 squared minus 21. This is vertex form. So that's how I taught it to you in class. But that's not the only way to do this problem. There's actually a different way. It takes a little more work, but I think that it might be a little bit better understood. So let me show you that other way as well. And the other way is just solving for the vertex and then plugging it in. And so we learned that in standard form you can find the vertex. You can start by finding the axis of symmetry, which is the formula negative b over 2a. So in this problem that would be negative 8 over 2 times 1, which is negative 4. So my y-coordinate for my vertex is negative 4. And then to find the x-coordinate, what we do is we take the negative 4 and we plug it into the original problem. Okay, and so we get 16 minus 32 minus 5, and that gives us negative 21. So my x-coordinate is negative 4, and my y-coordinate is negative 21. And then this is actually very similar to the chapter that we just did. We just took the test on it last Friday, right? And this is basically telling us our starting point. They want us to start by translating left 4 and down 21. So now I need to write that in y equals form. So when we want to go to the left, we actually write the opposite. We write plus, and we write it inside and attached to the letter x. And then when we want to go down, we write at the end, and then we write it exactly how it looks with the minus 21. And I hope you notice that this is the same answer that I got using the other method. Again, it's a little bit more work, but if you understand this method better, then that's definitely the method that you should be using. All right, and then it also said 46, so let's do that one. Trying to go in the order that you guys are asking. So on number 46, it told us the answers to the problem. That's what roots means. Roots means these are the answers. And so basically it said, you know, x equals 8 and then x equals negative 3. And it wanted to know what was the original problem that gave me those answers. So we're working backwards. And the first thing we want to do is try to figure out what were the parentheses that gave us these answers. And so to get an answer of positive 8, I had to have had a parentheses with an x minus 8, because then we would add the 8 to the other side, it would turn positive. And to get an answer of negative 3, we would have to have had a parentheses with x plus 3, because we would minus the 3 to the other side and turn negative. So these are the parentheses that those answers came from. And then what we do next is we multiply these together. You can do FOIL or the box method. And so I'm just going to do FOIL because I think it's going to be quicker. So x times x is x squared. And then x times 3 is 3x. And then negative 8 times x is negative 8x. And then negative 8 times 3 is negative 24. And we're going to finish off the problem by combining like terms. And this is my final answer. All right. Backing it up just a little bit, we'll go back and do number 42 now. Number 42 has multiple parts to it. And so they gave us a polynomial. And they also gave us one of the factors. They said one of the factors is x plus 5. And so the question wants to know, like, what are the other factors? What else do we have to multiply by x plus 5 to create this long thing? And so the first thing you're going to do is you're going to divide. You're going to divide this long polynomial by the x plus 5. And again, it doesn't say like how to divide it, so you can pick long division or synthetic. I'm going to show synthetic because I think that's easier. On synthetic division, don't forget that you take this number and you change the sign, so we're going to make it a -5. And then we take the coefficients from the polynomial, so 3, 20, 23, and -10. In long division, we start by dropping the first number down exactly how it is, so I'm just going to drop that 3 down below. Sorry, synthetic division. I think I said long division. And then we start multiplying. So we do 3 times the -5 in this little box, and that's -15. And then here, this is an adding problem. So 20 plus -15 is 5. And then we do 5 times -5 is -25. 23 plus -25 is -2. -2 times -5 is +10. And -10 plus 10 is 0, and that's exactly what we wanted to happen. We wanted to get no remainder. And then we count up, so the -2 gets nothing, the 5 gets an x, and the 3 gets an x squared. So now I have a trinomial 3x squared plus 5x minus 2. Now it did say it wanted the remaining factors, so we do need to take this thing and we need to factor it. So we get 2 parentheses. And so since this is a trinomial, we can do xbox. And I would have to multiply the first number times the last number. So 3 times -2 is -6. And then we put the middle number on the bottom. And two numbers that multiply to make -6 and add to make 5 are 6 and -1. Now be careful, it's not 2 and 3 because one of them has to be negative. And so the 2 and 3 won't work. But 6 times -1 is -6, and then 6 minus 1 is 5. So that does work. Now you have to remember that if there's a leading coefficient, if there's a number in the very, very beginning of the problem, that after you do the x, you do have to do the box. It is called the x box method. And so in the first box, I will put my first term, 3x squared. In the last box, I will put my last term, -2. And then on the diagonal, I'll take my numbers from the x, and I'll put an x next to them. I like to start by looking at the top 2 boxes and seeing what they have in common. Both those numbers are divisible by 3, and they both have an x. Then I'll move up top, and I'll ask myself 3x times what will make a 3x squared, and it's x. Moving to the next column over, this 3x times something up here needs to make 6x, and that would be a 2, because 2 times 3 is 6. And then moving to my very last spot down here, it's this x times something makes the -1x, and that's -1. And then we double check, -1 times 2 makes -2, so we did a good job. And then this would be my final answer. So I have 3x minus 1 and then x plus 2. And those are the other factors. All right, that was 42. So we are up to number 26 now. So there's a couple different ways that you can approach number 26. You could actually like try to solve it and see what kind of answer you get. and then use that to determine. We're looking for a phrase on this one. And you were supposed to memorize like 4 different phrases. Or you could do the discriminant. Our intention was that you were supposed to be doing the discriminant. So b squared minus 4ac. So that would be negative 5 squared minus 4 times 1 times 2. And that's 17. And so there's 4 different phrases that you were supposed to learn when we learned about this chapter for describing the nature of the roots. So the first phrase was if you had a positive number that was a perfect square, something that you could take the square root of, then the phrase was 2 real, unequal, rational roots. So 2 answers, they're going to be real numbers, they're not going to be the same number, and they're nice pretty numbers. You get like whole numbers or decent fractions. And then the next phrase was any other positive number in the world that you don't know the square root of. For instance, 17 is a positive number that I don't know the square root of. And for that scenario, I'm just going to add 2 letters to my phrase, and it's still 2, it's still real, it's still unequal, but now they are irrational. Irrational means like that there's going to be a square root in the answer. In this problem specifically, there's going to be a square root of 17 in the answer. Is it 5? I think that's the final answer to the problem. And so that's what irrational means. Irrational means it's not a pretty answer. It's not a nice answer. The other 2 phrases, just in case they show up on tomorrow's final, if you literally get a discriminant of the number 0, then you can say 2 real equal, and this is the only time you'll use the word equal, and it's rational because we do know the square root of 0. It is 0. And then finally, if you get any negative number in the whole entire world, then you get 2 imaginary answers, because then we'd be square rooting a negative. Oh no. Okay, sorry, I don't know what just happened. I think I pushed a button on my pen. Okay, so you'd be square rooting a negative number, and that always gives us an imaginary answer. So if your discriminant is negative, then you just say that there are 2 imaginary numbers, or 2 imaginary answers. 26 is in the first time we did chapter 4. So when we were learning about factoring and solving by factoring and solving by the quadratic formula, that was when we learned how to do number 26, chapter 4. All right, next there was a request for 41. So again, there's a couple different ways that you can do number 41. It just wants to know what the remainder is. So you can use the remainder theorem. The remainder theorem says take this, take the opposite of the number, and plug it in to the problem. So 2 squared plus 18 times 2 plus 5. And that's it. Now, if you can't remember that tomorrow, you could always just divide. You can do synthetic division, which also requires us to take the opposite of the number. So you could do 2 in the little box, and then it's 1x squared, 18x, and 5. And then we would drop the 1 straight down. 1 times 2 is 2. 18 plus 2 is 20. 20 times 2 is 40. And 5 plus 40 is 45. And we get the same answer. So that's 2 different ways that you can do it. Just, whatever pops into your mind first is what you should do tomorrow. They both give you the same answer. It doesn't really matter which method you use. All right, moving back to number 15. Okay, so 15 says they want an equation in slope-intercept form. And they gave us an ordered pair, 0, 1. They said it has to be perpendicular. And they gave us an equation, y equals 5x minus 6. So this is all the important information that we need. So we're going to start by finding the slope of the equation that was given to us. And we're going to kind of ignore the rest of the equation. We don't really care about anything else. All we care about is that the slope is 5, or 5 over 1. Next, we're going to take a look at what type of problem we're doing. And in this scenario, we're doing perpendicular. So I actually don't like the 5 over 1. When it's perpendicular, you need the opposite and reciprocal slope. And so opposite means change the sign. It's currently positive. I'm going to make it negative. And then reciprocal means flip it upside down. So negative 1 over 5 is the actual slope I'm going to be using. And then they want something in slope-intercept form. And so here I have an ordered pair, and I have a slope. And so now I'm ready to write something in slope-intercept form. I like to plug things into the slope formula and then just kind of manipulate it from there. There's several other ways you could also approach this problem. So if you want to see this done in a different method, just let me know. I can start in point slope form. We can start in slope-intercept form and solve for the intercept, whatever you guys want to do. But if we're doing slope formula, I'm going to put my slope first. Excuse me, hold on. Whew, okay. Notice that I put the negative on top with the 1 and not in front. And then on the other side, so this is my x1 and this is my y1. So we can do y minus 1 over x minus 0. And then from here, we're going to do some cross multiplying. So I'm going to multiply the 5 times the y, and we'll distribute it. So that's 5y minus 5. And then I'm going to do the negative 1 times the x. And we'll distribute it. We'll move the 5 over. And we'll divide, oops, it's not a 0 anymore. We'll divide everything by 5. And then that's the final answer. So that's one way you could do this problem. The most important thing is that you're using a slope of negative 1/5 and that you're using the ordered pair given to you and that you're not really using the rest of the equation. So we don't care about the minus 6 from the equation. If your teacher taught you a different way and you want to see a different way, just let me know. All right. Oops. Okay. So 40 is another division problem. And so on problems like these, you really want to pay attention to the notation that's written. So make sure that you're doing the right operation. So it's x squared minus 18x plus 65, and then it has a division symbol. And so that's just really kind of telling you, hey, you should do division. Specifically on this one, you can do synthetic. We're dividing by a binomial, and there's no number in front of the x. So synthetic would be great for this one. Remember, we take the opposite of that number, so I'm going to put a positive 13 here. And then I need the coefficients. So it's 1x squared, negative 18, and 65. I'm going to drop the 1 straight down. Then we do 1 times 13 is 13. Negative 18 plus 13 is negative 5. Negative 5 times 13 is negative 65. And then 65 minus 65 is 0. That means this problem has no remainder. And then the negative 5 gets nothing, and the 1 gets an x. And so the final answer would be x minus 5. Don't forget if there was a remainder. So if we got like 3, 2, 4, we would write 3x plus 2. And then the remainder gets written, it gets added at the end, and it goes on top of a fraction. And you put this thing on the bottom of the fraction. So that's what you would do if there was a remainder. Yeah, so number 49, we just wanted you to write anything, and it says it has to be a radical equation. So we want something that's like y equals the square root of x. And then it says it wants to reflect. So that means you're going to put a negative in front of the square root symbol. Dilate means stretching or compressing. It doesn't matter which one. That means you need to put a number up here. Now we don't care what number it is, right? So you got to pick the number. It doesn't matter. 372. We didn't tell you what number to use. And then the last thing it says is it translates to the right. And so translating to the left or the right needs to be somehow attached to the letter X. So I need to put that underneath the square root symbol with my letter X. And then we need to do the opposite. And so right is normally positive. We're going to put negative. And again, we didn't tell you what number to use, so you can put, whatever you want. And so we would just be expecting you, and the final tomorrow is multiple choice. So we might just ask you like which of these options is reflected and dilated and translated to the right. So you just need to identify, oh, I need one that has a negative number and something being subtracted. Yeah. Dilate, it means makes it bigger or smaller, and it doesn't specify which one. We also, in my class, were using the word stretch and compress. And so anytime there was a number being multiplied at the very beginning of the problem, like if there was a 2f of x, I told my students to call this stretching. That's more specific, but if you want to be more generic, it's called a dilation. Anytime you change the size of the graph, it's called a dilation. Okay, we're switching packets to the 78 question packet for numbers 65 and 66, which are cube root problems. So, and I can tell it's a cube root because there's a little 3 in the radical symbol. That means that it's not a square root. And so on square root problems, you always look for 2 of a kind because that's what squaring means. Squaring means something times itself. And so on a cube root problem, you're going to look for 3 of a kind because you want something times itself times itself. And so you're going to do factor trees. So I'm going to factor tree 750 is 75 and 10. 75 is 25 and 3. 25 is 5 and 5. And then 10 is 5 and 2. And so I have this list of numbers down here. And we're looking for 3 of the same number. So I do have 3. I have 3 number 5s. And so when you can find 3 of the same number, those get to go outside of the radical. Just one of them. You don't put all 3 on the outside. So one of them goes out, and the other 2 are just kind of gone. Any numbers that you can't find 3 of a kind, those stay inside the radical, and they get multiplied back together. So I'm going to multiply the 3 times the 2, and I'm going to leave a 6 in here. You can kind of do the same thing with the variables if you want. So x to the 8th means that I have 8 letter x's, and I'm looking for 3 of a kind. So 1, 2, 3, 4, 5, 6, 7, 8. And so from an 8, I was able to make 2 groups of 3, which means that 2 x's will come out, or x squared will come out. And then I have these extra 2 right here that weren't enough to make 3. So those extra 2 will stay inside. And this is the final answer to number 65. 5x squared on the outside, and then the cube root of 6x squared. because I took the 25 and I broke it down into a 5 and a 5. So we actually kind of ignore the numbers that were able to be broken down more. You're really just looking at the numbers that are at the end of the line. So these two 5s, that 3, this 5, and that 2. And we'll do another one. We'll do number 66. Okay, so on this one, we have 256. I'm going to ignore the negative sign for just a hot second. We'll talk about that later. When I have even numbers, I always just like to divide by 2 until I can't divide by 2 anymore. So I'm going to do 2 and 128, and then I'll do 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So again, we're only looking at the numbers that are at the end of the line. We're not looking at a number that was split up into 2 different numbers. And we want 3 of a kind. So starting at the top, I have 3 number 2s here. I have 3 number 2s here. I do not have 3 number 2s here. So in total, I had 2 sets of 3 2s. And so 2 2s will get out, otherwise known as the number 4. These other 2 2s that did not have enough to make 3, those stay inside and they multiply back together, also to a 4. For my variable v, I had 5 of them, so 1, 2, 3, 4, 5. I have 1 set of 3, and I have 2 extras. All right, now for the negative sign, it's okay to have negatives underneath a cube root, because that's like -1 times -1 times -1. So you can have a 3 of a kind. And so if you have a negative under a cube root, it actually just means that your answer is going to be a negative number. So the letter I is only for square roots. So if you have a square root of a negative, then you would put an I in your answer. But if it's a cube root, then you just put a negative sign in your answer. And so this is the final answer for number 66, -4v, and then the cube root of 4v squared. Yeah. Just make sure we didn't do that one already. We're doing a lot of problems in the 40s. I will say that all of those problems are from chapter 5. So you want to definitely go back and review your chapter 5. Yes. Yeah. If it's negative, just solve like regular and then stick the negative sign on the outside. If it's a square root, solve like regular and put an I on the outside. But if it's a cube root, just put a negative sign. All right, on this one, we have a trinomial. We can do Xbox on this one. And so I have 24 and -10, and those two numbers would be -6 and -4. So -6 times -4 will make a positive 24, and then -6 plus -4 will make a -10. Now I don't have a leading coefficient in this problem, so I can go straight to my parentheses. However, I cannot start my parentheses with an x, because an x times an x only makes x squared, and if we look at the problem, my first thing was an x to the 4th. So if your first thing is an x to the 4th and your middle term is an x squared, you actually want to start both of your parentheses with an x squared. So x squared on both. And then I would put my -6 and my -4. From here, you do actually want to write out that they are equal to 0, so you don't really want to do this next part in your head. And then we'll solve for x. So I'm going to add 6. And then to get rid of the square, I have to take a square root. So I'm going to square root both sides. When I take a square root, I need to put a plus or minus symbol. That will guarantee me my two answers. And then I don't know the square root of 6. And if you factor tree it, it's like 2 times 3. So there will not be a pair of numbers. So I'm just going to leave it the square root of 6. This counts as 2 of my answers. In total, I need 4 answers. So right now I have 2 answers, positive rad 6 and negative rad 6. And then I'll get my other 2 answers from over here. So I'm going to add my 4. I'm going to square root both sides. I need to put a plus or minus symbol anytime I decide to put a square root in a problem. And then I do know the square root of 4, so I am going to go ahead and simplify that, and I get 2, plus or minus 2. And those are my other 2 answers, positive 2 and negative 2. So now I have my 4 total answers that I need to have for this problem. You want like inside the actual box or just the X, hun? Are you talking about this problem specifically? So the 24 came from the end of the problem. I'm right, I put that up here. And then the negative 10 came from the middle. And then I know if I'm going to multiply to make a positive number, then I need the 2 symbols on the sides to be the same. And if I want them to add to make a negative number, that means they both have to be negatives, because a negative times a negative is a positive, but a negative plus a negative is a negative. And then I just thought of numbers that multiply to 24. And if you're having trouble thinking of them, you can always make a list. So the numbers that multiply to 24, we can start with 1 and 24. But that doesn't work because that adds to 25. Then you can try 2 and 12. That also doesn't work because that adds to 14. Then we can try 3 and 8, but that adds to 11. And then we try 4 and 6, and we say, okay, I got it. 4 plus 6 is 10. So then I put the 4 and the 6 here. All right, going back to number 13. And this one wants to know what the x-intercept is. So anytime you want to find an x-intercept, you want to remember that the ordered pair for an x-intercept is x comma 0, which means that the letter y is the number 0. So what I can do is I can go here and I can plug in a 0 for the letter y, and then I just need to solve for x. And so my x-intercept is 5, or the ordered pair 5 comma 0. The other thing you can do, if it's written in standard form and we're looking for an intercept, you can cover up the letter that you are not looking for. So if we're looking for x, we can cover up y. And now we have a very simple math problem. 3x equals 15, and we can solve that in our head, and we get this 5. Yep, we can do that one. "50 questions on the final. Multiple choice, but you have to remember that that doesn't mean it's going to be easy. All of the options will look like legitimate options, like they're good answers to the problem. So it's really important that you can actually do all of the questions like on the scratch piece of paper. And then the classes are in about an hour and a half long. So about an hour and a half to do 50 math problems. Okay, the first thing we need to do on this one is we need to set it equal to 0. Usually when we're solving something like this, we want it to equal 0. I mean, they'll be similar to those. They might not be exactly the same, but they should be about the same topics. And then it does say we should be able to factor this one, so I'm going to factor out a GCF, which is the letter X. And unfortunately, that's all the factoring that I can do. So if I try to factor this more, negative 1 and 2, like the only numbers that multiply to make negative 1 are 1 and 1. And then to make it a negative, one of these would have to be negative. But 1 minus 1 is actually 0. So factoring does not work. I can write down one answer right now, though. One of my answers from the GCF is x equals 0. And then since factoring did not work for this one, we're going to have to do quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Oh, it does that every time. Underneath the radical, it's called the discriminant, is a double negative right here. So that's actually going to change to plus. So this will become plus 4 and not minus. And so it's negative 2 plus or minus the square root of 8. And 8 is 2 times 2 times 2. So a pair of 2's with a third one left over. And then we divide all of the outside numbers. Now it's important that you only divide the outside numbers and not the inside numbers. So we're going to divide all the outside numbers by 2, changing them all into ones. Now this first one is mandatory. You have to write it down because it's the only thing in that position. The second one we don't need to write down because it has something else right next to it. So I can just write down the square root of 2 and then a 1 under a fraction bar we don't need to write down. And so these would be the other two answers. Again, notice this is x to the third. There should be 3 answers. One of the answers is 0. And then we got our other 2 from the quadratic formula. Okay, we're going to move back to the optional packet, the 78 question packet, and we're doing question 62. Okay, so this one's kind of weird. It's not a trinomial, and so I can't do like Xbox or anything like that. There's no GCFs, but it does have 4 terms. And so my first instinct when I see something with 4 terms is let's try to put it in a box, see if that works. So I have x to the 6th, 5x to the 4th, negative 9x squared, and then negative 45. So starting with the top row, these two do not have any numbers in common, but they do have an x in common. And then I want to take out the smallest exponent, which would be x to the 4th. Going up here, this number times that x to the 4th that I just wrote down needs to make x to the 6th, so that would be an x squared. The next column over, I have an x to the 4th, but I need it to be a 5x to the 4th, so I'm going to put a 5 here. And then right here on the bottom row, I have an x squared up here, but I need a negative 9, so I'll put a negative 9 there. So now I have x to the 4th. That is so annoying. X to the 4th minus 9, and then x squared plus 5. And then I'm going to see if I can factor this more. So I cannot factor the x squared plus 5 because it doesn't have a minus sign and because I don't know the square root of 5. So I'm just going to leave that one alone. But I can factor the x to the 4th minus 9 because it does have a minus sign and I do know the square root of 9. So that's going to turn into x squared plus 3 and x squared minus 3. This is called a difference of squares. And then the x squared plus 5 still needs to be there as well. And then from here, we're going to set all of these equal to 0. And we just did a problem very similar to this with the x squares. So I'm going to move everything over. And then I'm going to square root everything. So on this one, again, don't forget your plus or minus signs. Because it's a negative 3, it's an I. And then I don't know the square root of 3, so I just leave it as square root of 3. You can do guess and check and synthetic division, but the box is faster. Or you can do factoring by grouping if you prefer factoring by grouping, like this. I would not suggest guess and check just because that does take a very long time to do. I will say too though that, you know, some of the problems in the optional packet were really difficult. This is probably more difficult than a problem will be on the final. Okay, and there's my answers. We need 6 answers to this problem because it was an x to the 6th. And so each of my boxes gives me 2 answers because they all have those plus or minus signs. All right, I'm going to go a teeny tiny bit out of order just because we're already in the optional packet. So let's go ahead and do 61 from the optional packet, and then we'll go back and do number 39 in the mandatory packet. Excuse me, hold on, I'm going to get another drink. Okay, and we actually did a problem similar to 61 from the mandatory packet. It was, which one was it? There's another one where we had to sing the song. Number 44. Number 44 in the mandatory packet is very similar to number 61 in the optional packet because there are both cubes where you want to sing the song to factor. So we're going to sing the song. And it goes, you take the cube root of the first and the cube root of the last and the sign from the middle. Then square the first, change the sign, multiply together, and square the last. And so we get this when we factor. Our first parentheses gives us a very quick and easy answer. It's -2. And anytime you have to sing the song, you will need to do quadratic formula. For the second parentheses, it will not factor. So the quadratic formula is -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Oh, 12 is 4 times 3, which is 2 times 2. The negative's going to hop out. And once again, we can divide all of these by 2, leaving us with a final answer of 1 plus or minus I rad 3. That counts as 2 answers, and the third answer is over here because we do need 3 answers total. These cube problems keep showing up, so make sure that you are okay at factoring a cube. All right, back to the 50 question packet, and we are going to do question number 39. Okay. Question number 39 shows how important it is that you pay attention to the little things. You pay attention to notation. And the real, tip off in this problem is the symbol that is in between the 2 parentheses. Right here. It's a plus sign. This is an adding problem. All you have to do is combine like terms. Okay, so I'm going to start with the biggest exponent, which is this one, and that one does not have anything to combine with. Next, I'm going to combine my 3m with my 7m. Finally, I will combine my -9 with my 12. That's it. Substitution, usually it's set up where it's like y equals something, and then you take this and substitute it into the other problem. Elimination is usually set up as standard form, and they're stacked on top of each other, and in that problem you're trying to eliminate a variable. But those are both for solving a system, which is chapter 3, I want to say. All right, question 31. And on your final tomorrow, we won't have any way of knowing which method you used. We will just know, like, did you get the right answer? So um, don't worry about, like, if it probably won't even tell you which method to use. It'll probably just say solve this thing. And so you can do substitution, you can do elimination, you could even do graphing if you're comfortable with graphing. All right, 31 looks like this. This is a perfect problem for a multiple choice test because there's only 4 options for what the answer could be. The answer can be I, -1, -I, or +1. That's it. Those are the 4 options you have to choose from. And so, oh gosh, that was not where I wanted to draw that line. So what you're going to do is you're going to take your exponent and you're going to divide by 4 because you want to figure out which of the 4 options it is, and you'll get an answer. And for the answer, you're really going to focus on the decimal part of the answer. If the decimal is 0.25, otherwise known as 1/4, you're going to pick the first option, which is the letter I. If the decimal option is 0.5, otherwise known as 2/4, you're going to pick the second option. If the decimal portion is 0.75, otherwise known as 3/4, you will pick your third option. And if there is no decimal, otherwise known as a whole number, you will pick the fourth option. Okay, so you're just going to divide it in your calculator. When I do 241 divided in my calculator, I get 60.25. And so since it's 0.25, I'm going to pick the first option. And so my final answer is the letter I. You're welcome. Do you guys have any other questions? I think I've done everything you've asked so far. So I need to know if there's more questions. Oh, graphing, okay. Cassie, the second one, -b/2a, and that just gives you the x-coordinate of the vertex. Yeah, there can be word problems. I think there's one. Is there not one in your packet? Maybe I'm thinking of the optional packet. There's definitely a word problem in the optional packet. Something about like senior tickets and children tickets. Number 33 in the optional packet is a good example of a word problem that might be on your final tomorrow. Oh, I already forgot which one was asked. Number 20. Graphing. All right. So when you're graphing something with inequalities, you have to do shading as well, and you need like solid and or dotted lines, and so it just makes things a little bit more. You got to do a little bit more work. Yeah, I don't remember seeing. I don't see one right now in the mandatory, so I would say that that one in the optional is the best one to study for the word problems. There can be word problems tomorrow. Or Friday, whichever day you personally are taking the final. Okay, so on this one, we're going to start by graphing. We're going to go to the -3 on the y-axis, which is down here. And then my slope is 2/1, so I'm going to go up 2 and over 1. And this one has an or equal to underneath the inequality, and so I get to draw a nice straight line, solid line, nice straight solid line. And then we need to figure out which half of the graph to shade. And so I always like to plug in the origin as a test point for the y and for the x, and then I'm going to test and see if it is true or false. Ooh, I already did that. But if we have extra time, I can show you again. Yeah. But if we don't have extra time, you can rewatch this video once the session is over. And I think that was question number 36. So I did already do number 36, but we can do it again if there's extra time. All right, so going back to number 20, this says 0 is smaller than negative 3, and that is false. 0 is not smaller than a negative. And that means I don't want to color where 0, 0 is, so I'm going to color this side of the graph. And then they gave us a second inequality, x minus 3y is greater than 6. And I'm going to go ahead and just change this to slope-intercept form because that's a little bit easier to work with. And then I'm going to graph it from there. So here I have negative 2. And then the slope on this one is 1/3. So up 1 and over 1, 2, 3. So it's over here. If we look at the original inequality, there's not an or equal to sign, so I need to draw a dotted line for this one. And then we can do the same thing where we plug in 0, 0 to the original problem to see if it's true or false. So this one gives me 0 is greater than 6. That is also false. And so I don't want to color where 0, 0 is, so I will color below the line. And then where this crisscrossy section happens, that's where you're going to shade in darkly. And remember that any dot in the darkly shaded region is considered a solution, an answer to the problem. Oops, I went too far up there. Ignore that part right there. Also, any dot that's on a solid line next to a darkly shaded region is considered an answer. So places where there are not answers, there's no answers in the white space or in the lightly shaded regions. There's no solutions on a dotted line. And there's no solutions on a solid line that's like far away from the shading. Number 40, the answer is x minus 5. We did do that one in this session, so again, you can rewatch it when we're done to figure that out. Do we have to plug in 0, 0? You have to plug in something. You got to figure out which way to shade. You can't just look at the inequality because look at the one I graphed in black. The inequality is pointing to the left. That would have had you shading this side, which would be the wrong side. So you have to plug in something to figure out which side to shade. I usually plug in 0, 0 because it's just the easiest to do mathematically. But the only stipulation is you have to plug in a dot that's not on the line that you drew. So you have millions of options of what dot you pick for your test point. It doesn't have to be 0, 0. Yeah, if it's false, you want to color where the dot does not exist. So if it's like this and you tested here and you said that's false, that means everything on this side is false, and so you would color this side. If you test this dot and it's true, that means that everything on this side works, and so you would color this side. So you want to shade on top of the test point when it's true, and you want to shade away from the test point when it's false. All right. So Cassie, I think I answered your question about the vertex. It's x equals negative b over 2a. That gives you your axis of symmetry, your x number. And then you would take that number and you would plug it back into the original problem. We did do a problem like that on this video, so you can go back and watch that again later. There can be word problems. Again, I think there's like one sample in the optional packet. I don't even remember what number it was anymore. Number 33. So number 33 is a good word problem. So f of x versus y equals, if they tell you what type of problem it is, like if they're like, it's a quadratic, it's a radical, It's an absolute value. Or if you look at the picture and you're like, oh, that's a quadratic, that's a radical, that's an absolute, nope, I switched those. Scratch that, sorry. Radical, absolute value. So if you can tell what type it is, then you want to do the y equals format. And you want to be very specific. A quadratic is something squared. A radical should have a square root, and an absolute value should have absolute value symbols. If it literally just says like, hey, here's a function, and it does stuff, but it doesn't tell you like which function it is, then you want to use functional notation, f of x. So f of x is more generic when we don't know exactly which function it is. If we know exactly which function it is, it's actually better to write it in the y equals format. Number 19. We can totally do number 19. X plus y equals 4. I do recommend changing everything to slope-intercept form. It's just so much easier and it's so much more accurate. So I'm going to do this. And then we graph. So we're going to start at the positive 4 on the y-axis. 1, 2, 3, 4, right here. And then my slope for this one is negative 1 over 1. So from here, I go down 1 and right 1, which is right here. And we can keep doing that, down 1, right 1, down 1, right 1. We could also go up 1, left 1, up 1, left 1. So you can go in both directions. It does need to be like a negatively slanting line, though. So we're going like this. So that was the first line. And then for the second line, in front of the absolute value signs. Again, I'm also going to change this one to slope-intercept. So y equals 4/3 x plus 4. So this one also starts on the 4, so it starts in the same spot. And then the slope is positive 4 over positive 3. So 1, 2, 3, 4 up, and then 1, 2, 3 over. So somewhere up here. You can also go 1, 2, 3, 4 down, and 1, 2, 3 over. So you can go in both directions. It is a positive slope. The double negative canceled out. So you do want an upward sloping line. And so this is what the graph looks like. And then I'm going to assume on your final tomorrow, it's actually going to ask you for the solution. And so the solution is where the two lines intersect, which is this point right here, which is the ordered pair 0, 4. So we didn't actually ask you for that on the packet, but I mean, that's probably what we would ask you for on tomorrow's test. So that's kind of the whole point of this problem. Okay, yes, so it looks like the next thing that we've not done yet would be number 33 from the optional. And then I do see number 28 from the mandatory. So we'll do 33 and then 28. Make sure I'm looking at the right packet. Okay. So number 33 from the optional says, the school that Crystal goes to is selling tickets to the annual dance competition. On the first day of ticket sales, the school sold 19 senior citizen tickets and 7 child tickets. Oh, that's okay. Somebody else asked for it too, hon. And the total was $310. And then it says the school took in $169. That's a total, so I'm writing it over here with the other total. On the second day by selling 4 senior tickets and 13 child tickets. And then they want to know how much it costs for each one. So this is a system, and we can use substitution or elimination. This one is best suited for elimination because none of the variables are by themselves. All of the variables have numbers in front of them. So it's just not really good for substitution. It's best for elimination. Like exponential growth. Like this. That's something to the power of x. All right, so if we're going to do elimination, we need to have one of the variables have the same number. It doesn't matter which variable. When I was doing it, I chose the letter x, probably because I liked the number 4 better than the number 7. And so I'm going to multiply the top equation by 4. And then I need the bottom equation to be the opposite sign. So I'm not just going to multiply it by 19, I'm going to multiply it by a negative 19 so that it turns into a negative 76. And then we add straight down. So 76 plus negative 76, those will cancel or eliminate. 28 plus negative 247 is negative 219. And then 1240 plus negative 3211 is negative 1971. We divide by a negative 219. In this problem, since we're finding out how much a ticket costs, it would be appropriate to get a decimal. It would be okay. We don't get a decimal. It is a nice whole number. It's 9. But it would be okay if you would have gotten a decimal because money can have decimals. All right, so I just figured out that my y is the number 9. And if I look up here, I had written down earlier that y was a child's ticket. So I now know that a child's ticket is $9. And then we just need to find the senior citizen ticket. So we're going to take this y equals 9, and we're going to plug it into one of these equations up here. I'm going to choose the bottom one because I think the numbers are smaller. So that's 4x plus 13 times 9 equals 169. 17. And again, it would be appropriate. It would be okay if you got a decimal. We don't get a decimal for this problem, but it would be okay if you did. And so this is 13. And then up here, I wrote down that X is senior. So I now know that senior tickets cost $13. If you're talking about our most recent chapter, it's this graph. It's the exponential one. All right, so we're going to go back to the mandatory packet, and we are doing number 28 next. I'm going to switch. So I solved number 28 a little differently. I didn't like factor or anything like that because there's only one letter X in the problem. So I just got the letter X by itself. So I'm going to minus the 20 from both sides. I'm going to divide by 5. And then to get rid of a square, I square root. And anytime you square root, you have to put a plus or minus. I know the square root of 4, it's 2. And since it was negative, I need an I. And those are my 2 answers. This problem has 2 answers because it was x squared. My 2 answers are positive 2i and negative 2i. All right. Cassie and Delaney, did I answer all of your questions? I feel like I was randomly answering them throughout. Awesome. I assume you guys are working together. Or Cassie, do you have any other questions I need to answer? All right. I think I answered all the questions that were typed in. I am willing to stay on for 10 more minutes if you have more questions. I had planned on staying on until 9:30 if there were questions. If there are no more questions, I'm also totally fine with signing off early. So you guys tell me if you need more help. Yes, what is your question? Oh, totally. Exponential graphs have different equations based on what the number is. So you really have to pay attention to this number that has the exponent on it. So this one would have a table. It's 1/2, 1, 2. But if I change it to a 3, now it's 1/3, 1, and 3. And if I make it a fraction instead, now it's 2, 1, 1/2. Or if I make this a fraction, now it's 3, 1, 1/3. Right? I could put any number here. 7 would be 1/7, 1, and 7. So you have to pay attention to what the base number is, and that will determine what these numbers are. Yes. Do you want to, Trinity, oh, how to graph it. Okay, never mind. I just read the next line. Just kidding. So when you're graphing something like this, you want to find your axis of symmetry. This is also going to help. Ooh, somebody asked earlier about changing from standard to vertex. So we can totally do that right now as well with this problem, okay? So, so finding your axis of symmetry, the formula is negative b over 2 times a. And that, oops, that's positive 10. So, and that's going to be my x-coordinate for my vertex. And then we're going to take this and we're going to plug it back into the original problem. Now on this one, you have to be a little bit careful. So this negative sign right here, it's kind of like saying -1 times x squared. So just be a little bit careful with that. Oh my gosh, that looks horrible. Hold on. Okay. Be careful with that negative sign. Okay, so this is -1. This is 100. That's -100 plus 200 minus 75. It's 100 minus 75, and that's 25. So then your y-coordinate would be 25. And then you would graph that. This is your vertex. This is your starting point. And then you do your special order pairs, right? 1, 1a, 2, 4a, 3, 9a. In this scenario, a is -1. So from here, you would go over 1 and down 1, over 2 and down 4, over 3 and down 9. All right, and then I hope the person that wanted to know standard to vertex is still on. You can totally do this to go from standard to vertex. So you can do all of this work and you can find your vertex, and then what you do, I'm just going to clear a little bit of space. For vertex form, it's y, oops, need to switch back to the pen, y equals a x minus h squared plus k. And so what you do is you do x, and then this number is telling us to go right 10. And then in our most recent chapter, we learned that when you go to the right, it's actually minusing. And then this is telling us to go up 25. So I'm going to do plus 25. And then the letter a from right here, the -1, is the same letter a for right here. So you can just stick a -1 right there. And now this has been changed to vertex form. So that's one way that you can go into vertex form. You do not have to do completing the square if you don't want to. You can calculate the vertex and then just plug the numbers in. Just make sure that you're doing the opposite sign for the x number. So I don't think YouTube is working. I don't know that any of these have been posted on YouTube at all this school year. What you can do, if you can watch from a computer, you can watch it, just click on the link to it, not the YouTube link, but like the actual link. You just need something that has Adobe installed on it. So I think that you can watch this from a computer or I don't know if it's compatible on a phone, but I'm going to post it as soon as we sign off. So I would say by like 9:45, you could watch it from a computer, just not necessarily on YouTube. I've done several with the song tonight, so you can again go back and watch the other ones. I just want to make sure that I'm answering the questions in the order that they were asked. Andrew, 39 is the box again. Do you want me to do the box, or do you want me to do like try factoring by grouping and see if you like that better? Okay, let's try grouping. So for factoring by grouping, you group together the first two terms and the last two terms, and then you focus on just the first two, and you ask yourself, what do they have in common? What's their GCF? So 15 and 40 are both divisible by 5, and then x to the third and x squared, they both have an x squared in common. And then you're like factoring out the GCF. So 15 divided by 5 is 3, and then x, and then 40 divided by 5 is 8. And then you do the same thing over here. You look for a GCF of just those two numbers. So 9x and 24, first of all, they do not both have x's, so I'm not going to put an x there. But 9 and 24 are both divisible by 3. And then we divide it out. So 9 divided by 3 is 3, and then 24 divided by 3 is 8. And then the really important thing on factoring by grouping is that these two parentheses have to be exactly the same. If those two parentheses are not exactly the same, then you made a mistake, or it can't be factored by grouping. If those two parentheses are exactly the same, you're going to factor them out to the front, but you only write it one time. And then you kind of ignore those parentheses, and you take this outside front stuff, and that gets its own parentheses. And this would be the final answer. Oh, I'm so sorry, Trinity. I didn't see your question till later. No, you can't just look at it and graph it. You do have to do some calculations. We can try one more with the song. I'll just write a random one up here. No. Okay. So the song goes, you take the cube root of the first and the cube root of the last and the sign from the middle. Then square the first, change the sign, multiply together, and square the last. So that's the cubing one. Yeah, after you say the word then you're looking at these numbers here, and you're not doing these numbers anymore. You're welcome. I have 3 more minutes if you have a quick question. We already did 46. Oh, 46 is quick though. We did already do it, but that one's really quick and no one else is asking, so we can totally do that one again because it is fast. So number 46, they told you that the answers are 8 and -3, and they just want to know what the original problem was. So you're going to write down the parentheses that would give you those answers. So like to get an answer of +8, you have to do x minus 8 for the parentheses, because then you would like plus it to the other side. And to get an answer of -3, you would have to have x plus 3. Then you would, subtract it to the other side. And then you multiply these together. You can do foil or the box. I did foil earlier, so I'll do the box this time. So this is x squared, 3x, negative 8x, and negative 24. And so the final answer is x squared minus 5x minus 24. So again, they just wanted to know, like, what is the original problem that gave us those two answers? Yeah, I think a lot of people were overthinking that one. Because a lot of people asked for that one today, and I was a little bit surprised. I think we just didn't remember. Yeah, that's the song. If we skip the quadratic form, can we skip the quadratic formula, or do you need to see that part too? Okay, so we're going to sing the song again. It is, you take the cube root of the first and the cube root of the last and the sign from the middle. Then square the first, change the sign, multiply together, square the last. Okay? This gives you an answer of 4. This is quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. What is that? 4, right? Yeah, 4. I did it a little bit faster this time. But we did do this one earlier, so you can go back and watch it, and I did it slower, and I explained what I was doing when I was doing it. So here I did a factor tree on 48, and it turned into 2, 2, 2, 2, 3 when I did the factor tree, like when I was done. So I had 2 pairs of 2's, which became this 4, and then the 3 stayed inside. And since it was a negative 48, I put an I out here. And then my very last step, I divided all the outside numbers by 2. I don't think it's going to be an issue on the final just because it's multiple choice. So you will be able to look at the answers given to you and you'll know when to stop. We're not going to have answers in multiple different formats. We will just have multiple different answers. So we're not going to have a problem where like the first answer is x plus 3 and x plus 5 and the like that's option A, and option B is like negative 3 and negative 5. That's not going to happen. The options are either going to be all the parentheses options or all the x equals options. So I don't think that you'll have an issue of when to stop because you'll be able to look and see what the answer should look like. Yeah, so I don't think that'll be an issue tomorrow, hopefully. All right, guys, I'm ready to go, and so I hope this helped you. As soon as we sign off, I am going to post it online so that you can go back and watch it if you need to, and best of luck to you guys on your finals.